Hello and welcome back to our final episode in this mini-series on understanding and mitigating the risk of internet-connected industrial systems. My name is Joel Angel. I'm the founder of the Industrial Control Systems Cybersecurity Institute and also the founder of the popular website SCADAhacker.com. I was invited by Phoenix Contact to join them as we celebrate and educate during National Cybersecurity Awareness Month. And in this mini-series, we've been talking about what happened with a real actual case study where a small industrial site was inadvertently connected to the internet unknowingly, discovered during a cybersecurity exercise. We went and we did initial analysis, collected data, and found significant indicators of hostile foreign actors that were interacting with this control system. So now we're going to talk about what we did to solve this problem. So to begin with, this is an existing facility. So it's all packaged in a very small physical environment. So the first thing we had to deal with when we started to address the solution was it had to fit within our existing mechanical environment. I only had about 2 inches of available rail space. So whatever I did, I needed it to fit inside that cabinet with the small rail space that was left. Also, no matter what I did, the only power I had available was 24 volt DC. So I had to make sure that my installation was able to run in an environmental area that's subjected to high and low temperatures, high and low humidity, and in a DC-only power system. Now, a lot of products provide what's called deep packet inspection. So maybe you would think, hey, we could prevent these from doing any kind of write or configuration changes on these endpoints by implementing some kind of application layer filter. But in this particular case, that's really not important. There's a significant cost usually to get that, and we really didn't need that to address the risk that we were faced with in this particular case. What we wanted to do was we wanted to create a solution that established some kind of rule-based rules and policy. What we wanted was a user role that allowed someone to access operational graphics and view logs, and we wanted a separate maintenance role that would be used for configuration. So remember, there was no firewall. When I was able to do my port scanning of this particular site, all ports and services were exposed. And the reason is that the initial installation did not know where the user would be that would access this particular system. So they needed the ability to leave these ports open. We want to close these down. That's a #1 rule in security, is we want to close unused ports and services, and we want to limit people to only the ports and services they need to do their job function. So we're going to do that, and we're going to implement some new authentication in the form of digital certificates. So that will allow us to do authentication for sensitive configuration related information. And the beauty of using digital certificates is there's no risk of loss or brute force hacking against passwords. Because remember, we saw that some of those actors that were accessing this equipment were trying to brute force the operator panel passwords. So we want to move above username password and get into a digital certificate-based solution. So what I did was I went in, and this is actually a block diagram of how that system was built out. So on the very top, we have a Sierra Wireless common cellular wireless gateway. And on that, it provides a basic modem, cellular modem that connects with the infrastructure, and then an Ethernet port on the inside that you can then connect to a switch or whatever. In this particular system, it was connected directly to the Seymour panel. Now this Seymour panel had several services that it offered. We saw that in the first episode of the mini-series. So it had a login type display that was hosted by a built-in web server. It had an FTP server so that it could host logs, and then you could extract those logs if you wanted. It had an SMTP, a simple mail transport protocol access mechanism, so that it could send emails, right? We wanted to be able to extract daily reports of the particular system. So it did have an email client, not an email server, to send out these reports. And then it also had support built in for a couple different flavors of PLC. And in this particular case, the Rockwell Micrologics run an Ethernet IP on TCP port 44818. So then down to the bottom, you see we have the Micrologics PLC on the lower right, and on the lower left is the Automation Direct. So what we did was we put in line a new firewall. And this firewall, remembering all the requirements, 2 inches, DC powered, and the ability to support user profiles with digital certificates so that one person could access it with maintenance capability and another without, only basic user. That's why the choice was made for the RS4000. It provided everything we need plus basic firewall access control mechanisms. So what we did is after this was placed into service, we created 2 user profiles. These user profiles effectively create 2 independent rule bases based on how you authenticate into the RS4000. Now, I do say RS4000, all of these Phoenix Contact firewalls do support this capability. They're just in different packaging form factors based on what you need. The one reason I like the RS4000, in addition to being 2 inches wide, less than 2 inches wide, it also provided us multiple ports so that we could simply take out the old existing Turk switch that was in there and slide this in its place. So we had the switch functionality and the firewall capability. So here we built those 2 user profiles. So we had one for user and one for maintenance. Then what we were able to do was say, hey, the maintenance function needs those high-risk ports. For instance, that's where we needed access to the Rockwell stuff. We needed 44818 so that we could go in, remotely modify the logic in the PLC. That happens rarely. So the 99.99% of the time, we don't want that rule open. So the user rule eliminates those configuration services from being exposed on the internet. So now we have a very hardened environment. So the same person could log in both ways, but we have a different profile so that the daily logins that occurred in order to obtain operational information would not expose engineering, maintenance, configuration type services to them. So very, very powerful. This solution was accepted immediately by the end user because they liked it. It simplified administration and it simplified use without changing any of the functionality. The control system still did what it did before. The same reports were being generated that it was sending out. However, it started to secure infrastructure that was not needed. For instance, that FTP server. It's still running on the Automation Direct Seymour panel. However, if you don't log in as a user or a maintenance person, you can't access the FTP server. So no more brute forcing. No more people trying to go in and see what's on that particular server site. Now the beauty of this is after a small period of time, remember Shodan is this crawler that just continually scans all of the global IP address space. And eventually it will lose information from an IP address that it had. So I commissioned this particular product, and the scan that I observed, or the crawl I should say, from Shodan occurred about every 2 weeks. So depending on where I was in the cycle, I figured I would need safely 2 crawls in order for us to start to see the benefits of the solution. And in fact it did. By the 6th week, our entire indication of this site effectively disappeared from Shodan. No longer does it have that big red industrial control system. No longer does it say Rockwell or an FTP server with the client's name on it. It's all gone because it's all hidden behind that RS4000. And Shodan doesn't have a digital certificate to authenticate in, so Shodan cannot see it. All Shodan was able to catalog were 3 ports and services on this particular site. Now, of course, one of them is going to be the 443 that we need to initiate the TLS session with the firewall to perform our authentication. The other 2 ports that are open, we cannot control because those are the ports that are configured within the exterior device, that Sierra Wireless modem. Now, those are actually not, there's no function running against them, so Sierra Wireless does not let you make those ports go away. They're just on, but there's no action. So there's no executable running against those particular ports. So even if you tried, you would not be able to establish any form of connection with it. So the customer was ecstatic with the solution. It was a very simple, inexpensive solution using built-in capabilities. Nothing was custom. I was able to replace everything in place, and their risk was almost completely eliminated. From high, aggressive, and dangerous to very low, minimal, and simplistic in operation. The only thing that we have to do is on a periodic basis, we need to update those digital certificates. Because again, a good security practice is to limit the longevity of those particular certificates. So I hope you've enjoyed this 4-episode mini-series on how we actually understand and, more importantly, mitigate risk of devices that have to, in some cases, be connected to the internet. There's a lot of information here, and I sure hope that if you have questions, you'll reach out to your Phoenix contact representatives to guide you through this wonderful and powerful solution and how it can be deployed to really address immediate operational risk that you face in your infrastructure. So again, I'll say thank you for attending. This is Joel Angel signing off and hoping that you have a very great October as we celebrate National Cybersecurity Awareness Month. Thank you.